Hello 11th class students. Our next topic is to find the relation between alpha, beta and gamma. Alpha is a coefficient of linear expansion, beta superficial expansion, gamma coefficient of cubical expansion. Now we have to find the relation between these three terms. Clear? So we start with, as we know, L dash minus L equals to alpha L delta T. We derive this equation. L dash minus L is equals to alpha L delta T, right? On the left hand side there is a minus L. When we take this to the right hand side, it becomes plus L. So we have L dash is equals to L plus alpha L delta T. Clear students? Now scaling on both sides. Scaling on both sides. Scaling on both sides. Scaling on both sides. When we scaling on both sides, we have here it is L dash square equals to L plus alpha L delta T whole square. Now here we use the formula A plus B. This is B. A plus B whole square. The formula is A square plus B square plus 2AB. Right? So as we know, surface area or area, it is equals to length into breadth. Right? As we know, area of a rectangle or a square, we can find it at length into breadth. Here we have L dash square, means this is equals to S dash area, L square S plus alpha square L square S delta T square plus 2 L raised to power 1. 1 plus 1, 2. L raised to power 2 means S alpha delta T. Clear बच्चे? ठीक है? Now this equation can be written as S dash minus S equals to, we take this S on the left hand side, S dash minus S equals to, as delta T is very small temperature and its scaling become very small, very small. So this terms we neglected, right? Due to the scaling of delta T. Delta represents the very small change in anything. For example, if we take 0.02 square, very small change, it's a square, means 0.0004. Clear? So this is very small. So we neglect this term. And we on the right hand side, we left only with 2s alpha delta T. And from the definition we have S dash minus S is equals to beta S delta T. Clear? Compare both equation. Left hand side of both the equation is equal. So we can equate the right hand side. When we equate the right hand side, we get 2s alpha delta T equals to beta S delta T. Delta T cancel. S and S cancel. So we have beta is equals to 2 alpha, or we can also write it as alpha is equals to beta by 2. Clear? So this is the relation between coefficient of linear expansion and superficial expansion. Now we have to find the relation with the cubical expansion, right? For cubical expansion, cubing on both sides of this equation, we start with the same relation and instead of squaring we use cubing. So we use cubing on both sides. Here we use the formula a plus b whole cube. So it is equals to a cube plus b cube plus 3a square b plus 3a b square. Clear बच्चे? This whole term we taken as a and this term as b. Now length into breadth into height, L cube means it is equals to volume v plus alpha cube, L cube means v delta t cube plus 3 L square and L raised to power 1 means it is 3 alpha v delta t plus L square means 3v alpha square delta t square. Now as we done in the previous, delta t square is very small term, so we neglect it, and delta t cube is also very small term, so we also neglect it. Then we left with only v plus this term get neglected, 3 alpha v delta t, this term is also neglected. Clear? Here we have v dash. Then take the v on the other side, v dash minus v equals to 3 alpha v delta t. Then from the definition of cubical expansion, v dash minus v is equals to gamma v delta t. Now compare both equation. As the left hand side equals, so we can equate the right hand side. Then what will we get? 3 alpha v delta t equals to gamma v delta t. Delta t cancel, v and v cancel. So we have 3 alpha is equals to gamma, or we can write it as gamma by 3 equals to alpha. So basically we have the relation between three coefficients as alpha is equals to beta by 2 is equals to gamma by 3. Clear बच्चे? So this is the relation between coefficients of thermal expansion, alpha, beta and gamma. To find the relation between alpha and beta, we start from the equation linear expansion, then scaling, and to find the relation of it with the cubical expansion, we cubing the equation of linear expansion. Clear? हाँ जी बच्चे, our next topic is specific heat. Specific heat, it is the amount of heat required to raise the temperature of 1 kg of substance through 1 degree Celsius or 1 Kelvin. Means for example, if we have any substance whose initial temperature is 30 degrees Celsius, and we want to change its temperature from 30 to 31 degrees Celsius, then how much heat we will given to that substance, that heat is called specific heat, right? Then thermal capacity of a body is defined as amount of heat required to raise the temperature through 1 Kelvin. And one thing more, specific heat in mathematical form, it can be represented by C. Specific heat equals to amount of heat required means Q, amount of heat required to raise the temperature of 1 kg of substance means mass of the object and temperature. Mathematically it is represented like this. Specific heat C is equals to delta Q m delta T. Clear? Then thermal capacity, then water equivalent. Water equivalent, it is defined as the mass of water which absorbs or emits same amount of heat as is done by a given body for the same rise or fall in temperature. For example, बच्चे, in one thing we have a water in one beaker and in other any substance. Mass of both the same, right? Then we heat particular both beaker water and which include a substance, right? If there is a same rise or same fall in temperature, they show the property, that substance shows the property like of water, right? Means if we give the same amount of it, both rise by the same temperature, 1 degree at same heat, right? So that body we should call it as it is equivalent to water. So this is called water equivalent, right? Then next we have the definition of latent heat. What is latent heat? You have read in your lower classes. It is the amount of heat required to change the unit mass of a substance from one state to another. Means one state to another means you have read in your lower classes 3 states of matter: solid, liquid and gases. So change one state to other state, what amount of heat is required to us, that it is called latent heat. Latent heat of fusion. Fusion means the amount of heat required to change the mass of a substance from solid to liquid. Means if there is a change in state from solid to liquid, in that case latent heat is termed as latent heat of fusion. Then vaporization, the amount of heat required to change the unit mass of a substance from liquid to gaseous form or vapor form. This is called latent heat of vaporization. Then principle of calorimetry. Principle of calorimetry बच्चे, a calorimeter it is a cylinder, right? calorimeter की एक cylinder है. Then made of copper and provided with stirrer. copper ਦਾ ਬਣਿਆ ਹੁੰਦਾ ਹੈ, ठीक है. stirrer fix ਹੁੰਦਾ ਉਹਦੇ ਵਿੱਚ. stirrer means जो ਆਪਾਂ ਘੁਮਾਉਂਦੇ ਆ mix ਕਰਨ ਲਈ ਕਿਸੇ ਚੀਜ਼ ਨੂੰ, right? Then it is used to measure the quantities by making the use of principle of mixtures. Means when we mix the two things in that calorimeter is a cylinder, we mix the two things in that, then the heat lost by the hot body, it must be equal to the heat gained by the cold body. Without, if we assume that there is no loss of heat by any method, right? कोई loss नहीं हो रहा है किसी भी method के नाल, then we assume that the heat lost by the hot body must be equal to the heat gained by the cold body. Clear? So this is called principle of calorimetry and it is also known as principle of mixtures, right? So when we mix a hot body with a cold body, they lose and gain heat by the same amount. Clear? So next बच्चे you have the applications of thermal expansion. All of you aware about it. Applications of thermal expansion. First one is, in laying a railway line, a small gap is always left the iron rails. Why there is a small gap between the rails? Because during summer more heat means expansion. So these lines may expand and cause accident. So to prevent accident, there is a small gap always left between their iron rails. Space is left between the girders used for supporting bridge. This is also due to the thermal expansion. In summer more heat and they absorb the heat and get expanded, right, which leads to accidents. So there is a space is left between this. Same the third application, the iron rim to be put on a cart wheel is always of slightly smaller diameter than that of the wheel. कि उसका जो diameter होता है smaller होता है iron rim का. Why? Same, when it get heated it becomes red hot and expands and slip onto the wheel easily. ठीक है, उसमें अच्छे से पकड़ आ जाती है wheel की, right? So when it is cool it contract and grip the wheel firmly. जब वो cool हो जाता है तो wheel को अच्छे से grip कर लेता है. Clear? If the wall of the building has bulged out, it can be set right by making use of the expansion of solids. Then for this we clamp the iron rod over the bulging portion. जो बेटा थोड़ी सी बल्ज आउट हो रही है, जब बल्ज इन हो रही है, ठीक है, उसके लिए आयरन रोड वहाँ पे क्लैम्प कर देंगे. ठीक है, जब वो कूल होएगी तो कॉन्ट्रैक्ट हो जाएगी एंड बल्ज जो होएगा वॉल में वो क्या हो जाएगा, रिड्यूस. क्लियर? सो दैट द क्लॉक्स कीप करेक्ट टाइम इन डिफरेंट सीजन्स, द पेंडुलम मेड ऑफ इनवार आर यूज्ड. सो अगर टेम्परेचर चेंज हो रहा है, डिफरेंट सीजन में टेम्परेचर क्या होता है, डिफरेंट, राइट। सो लेंथ ऑफ द पेंडुलम ऑफ अ क्लॉक एंड हैंस टाइम पीरियड चेंजेस, उसकी लेंथ जो होएगी वो भी क्या होएगी, चेंज होएगी ड्यू टू द चेंज इन टेम्परेचर, ठीक है। इसीलिए जो वो क्लॉक्स होते हैं स्लो डाउन हो जाते हैं समर में और फास्ट होते हैं विंटर में, क्योंकि समर में टेम्परेचर क्या होता है, ज़्यादा, लेंथ क्या हो जाती है उनकी, इंक्रीज हो जाती है। सो पेंडुलम मेड ऑफ इनवर्ड यू आर यूज टू रिड्यूस एरर ऑन दिस अकाउंट, इस एरर को रिमूव करने के लिए पेंडुलम जो है उनमें इनवार यूज़ किया जाता है, ठीक है, क्योंकि इट हैज़ वेरी लो वैल्यू ऑफ कॉफिशेंट ऑफ लीनियर एक्सपेंशन, इसकी कॉफिशेंट की वैल्यू क्या होती है, स्मॉल। सो टेम्परेचर का ज़्यादा इफेक्ट इसके ऊपर नहीं होता, ज़्यादा एक्सपेंशन नहीं होती है, क्लियर। अ ग्लास टॉपर जैम्ड इन द नेक ऑफ अ ग्लास बॉटल कैन बी टेकन आउट बाय वार्मिंग द नेक ऑफ द बॉटल। कई बार देखा होगा बिकॉज जो हमारे घरों में बॉटल्स होती हैं उनके टाइट जो ढक्कन होते हैं ऊपर वाले वो टाइट हो जाते हैं, उनको अगर हल्का सा हम गर्म करेंगे तो वो ईजिली से ओपन हो जाते हैं। उनका क्या रीज़न है, कि जो स्टॉपर्स होते हैं ग्लास बॉटल के वो जैम हो जाते हैं, जैम्ड, ठीक है, और उनको बाहर निकालना मुश्किल होता है। अगर उनको स्लाइटली वार्म करेंगे तो उनका माउथ जो है बॉटल का, ठीक है, वो क्या हो जाएगा, वाइडर हो जाएगा, मतलब एक्सपेंशन के कारण, और स्टॉपर जो है वो लूज़ हो जाएगा और इजीली उसमें से क्या आ जाएगा, बाहर। क्लियर, थैंक यू।